Okay, so let's talk about city air quality. Road transport is, well, obviously a huge source of pollution, especially in urban areas.
Absolutely. It's a major challenge everywhere.
But figuring out exactly how much pollution and from which vehicles,
Hmm.
that needs a proper emissions inventory, right? And that sounds difficult.
It really is. Especially for city planners, maybe in low or middle income countries. Building that detailed vehicle exhaust emissions inventory, the VEE, it's complex. Traditional ways can be super expensive, very slow.
Right, you need really specific local data, which takes time and money they might not have.
Exactly. That VEE inventory is, well, it's kind of the cornerstone for managing air quality effectively. It basically hinges on three things.
Okay.
First, the number of vehicles out there, you could call that the supply. Second, how much they're actually used the demand, often measured as vehicle kilometers traveled, or VKT.
Okay, supply and demand.
And third, the technology side. What kind of emissions are they actually putting out? That relates to things like their age, fuel type, their fuel economy, FE. Getting all three pieces accurate is tough.
That sounds like the real bottleneck, gathering those three locally. So today's deep dive is looking at a workaround, right? A simpler approach.
Precisely. It's called the Fuel Station Survey. Basically, it's a rapid assessment framework. It's designed to quickly get a profile of the vehicles actually being used in a city.
Fuel stations. Okay, why there? Why not, I don't know, registration data or something?
Well, the core thinking is pretty neat, actually. The assumption is simple. If a vehicle is genuinely in use, driving around, polluting, it doesn't matter how old it is, or if it's even registered locally, it has to stop for fuel eventually.
Ah, so the fuel station acts like a natural sampling point for the active fleet.
You got it. It gives you a snapshot of what's really on the road, contributing to emissions, without needing massive, slow, maybe even incomplete registration databases.
Interesting. But hang on, wouldn't that kind of skew the results? Like, you'd mostly catch taxis or delivery vans that refuel constantly and maybe miss the family car that only fills up once a month?
That's a really fair point, and it's a known limitation. It's something you have to consider. But think about the upside, the efficiency. They did a case study in Patna, India.
Okay, what happened there?
We got 19 trained students, surveyed people at 10 different fuel stations. About 10% of the ones they mapped over just 9 days.
9 days, and how many surveys did they get?
Almost 10,000. 9,775 cleaned survey points.
Wow, 10,000 data points in 9 days. That speed is incredible. That's the key advantage here, isn't it?
It really is. And they streamlined the process itself. The questionnaire was super short, designed to take like 2 or 3 minutes max, about the time it takes to refuel.
So people were willing to actually do it while waiting.
Exactly. They even used 3 surveyors per vehicle. One asked the questions, one just observed the vehicle make, model, condition, and a third cross-checked the info.
Efficient.
And they used a mobile app, ODK, so the data was digital immediately, no paper forms. This whole setup led to a response rate over 95%. People were happy to participate.
Okay, so super fast, high response rate, and the data they collected that feeds directly into those 3 VE components you mentioned.
Right. They specifically gathered the critical stuff, the age mix of the vehicles they saw, which tells you about the technology. They asked about usage, the VKT for the demand side, and they got fuel economy info, the FE part.
So what did they find in Patna? What did that snapshot look like?
Well, the sample was roughly 41% two-wheelers, 46% four-wheelers, the rest being three-wheelers and larger vehicles. And interestingly, the fleet was quite young. About 90% of the vehicles surveyed were less than 10 years old.
90% under 10 years. That's younger than I might have guessed. And what about how they were used? The VKT.
That's where it got really interesting. The survey clearly showed that diesel cars and diesel SUVs were driven much higher VKT than petrol cars.
Which suggests...
It strongly suggests they're being used commercially, as taxis for ride sharing, maybe small deliveries. They're covering a lot more ground each day compared to privately owned petrol cars.
That kind of usage insight is gold for policymakers, right?
Absolutely. It connects directly to policy. For instance, in Patna, because the survey showed less than 5% of the in-use fleet is older than 15 years.
Okay.
It means simply banning old vehicles probably wouldn't have a huge impact on overall emissions there. It might not be the most cost-effective first step.
So the data suggests focusing elsewhere.
Yeah, maybe focusing on enforcing stricter emission standards on the current younger fleet, or, making bigger investments in public transport to reduce vehicle use altogether, things like that.
But you mentioned limitations. This rapid survey, it's not a perfect replacement for those big comprehensive studies, is it? What are the main uncertainties we need to tell listeners about?
Definitely not a full replacement. The biggest potential issue is sample bias based on where you survey. A station in the city center might see a very different mix of vehicles compared to one on a highway or out in a suburb.
Makes sense. Different travel patterns.
Right. And you also inevitably capture some vehicles just passing through, ones not actually registered or based in the city. That dilutes the purely local picture a bit.
So how do you make the fuel station survey better, more representative, without losing that speed and cost advantage. That seems like the tricky part.
It is a balance. One idea is to diversify where you sample. Don't just use fuel stations. Maybe add survey points at shopping malls, office parking lots, big markets.
But wouldn't that add complexity and cost?
It would, yeah. More locations, different logistics. The other option is just bigger samples. Instead of sampling representing, say, 1% of registered vehicles, maybe aim for 5% or 10%.
But then you start running into the original problem again, right? More time, more resources needed.
Exactly. You start losing that racket assessment benefit. It's a trade-off.
So wrapping up, the main takeaway here seems to be that this fuel station survey method offers a really practical, pretty cost-effective shortcut. It helps cities establish a baseline emissions inventory, especially where data gaps are a major hurdle to, actually doing something about air quality.
That's the essence of it. It provides actionable data quickly.
A good starting point.
A really valuable starting point. And maybe the final thought for you to consider is this. Vehicle fleets change. People buy new cars. Usage patterns shift. So the real power of a framework like this isn't just doing it once.
You mean its repeatability?
Exactly. Relying on emissions data that's 5-10 years old isn't great for making effective policy now. Ideally, cities should be doing these kinds of rapid assessments maybe every 3 to 5 years just to keep the data fresh and ensure decisions are based on the actual current situation on the roads.